Hello everyone, today we will solve an equilibrium problem. Here in the figure we have a truss and the problem states in figure 56 find the forces in members AB, AF, BF and FE. Okay, to solve this problem let's draw a free body diagram at joint A. Here FBD of joint A looks something like this. Here that in the A point a vertical force of 200 tons is acting upward, and then in the rightward direction there is an AF member that has an unknown force and the angled AB member which has an unknown force. To solve this, we will first have to find out the angle between the AF member and the AB member. To do that, we will have to see the figure. There it says the base is 10 feet and the height is 10 feet. So if we use calculator, then we will get 10 inverse 10 by 10, then we will get 45 degree. So we can say that this angle is 45 degree. Now let's solve it. To do that, first let's find out the summation of all the horizontal forces. Since there is no horizontal force acting against the member AF, so we will get summation of f of x, where rightward is positive, equals 0, and since we have only one horizontal force which is AF, then it will equal to 0. And then if we focus on the vertical portion, then we will get summation of f of y, where upward is positive, equals 0. Then we will get at the A point there is a 200 tons acting upward, so we will take 200 tons plus AB, since AB is acting upward, but since it is making a 45 degree with the base, then we will say sine 45 degree equals 0. Then we will get AB equals minus 200 divided by sine 45 degree. Therefore the value of AB would be minus 200 divided by sine 45 degree. We will get minus 282.84 or 282.84, which is in the minus. Notice that here we get a minus in the value in the force. So since it is minus, so we will take it as compression, so it would be C. So we can say that AB member is in compression. Here we can see that we already found AB and AF. AB and AF. Now we will have to find out the BF and the FE portion. To do that, we can draw a FBD of joint F, and that will solve these two unknown component. So let's do that. Here FBD of joint F, then we will get something similar to this. Here 200 pound is acting downward, 200 tons, sorry. Then we will get this would be the FB portion of the joint, and this would be the AF portion of the joint. and this would be FE. Notice that here we have two unknown, FB and FE, or we can say BF or FE. And since we have found the value of AF from the previous one, so we are known to this force. Let's draw a free. Okay, now let's summation this from the horizontal axis, and let's take again the rightward as positive equals 0. Then we will get, since AF is pushing leftward, so it would be minus AF and then plus FE equals 0. Since we know that AF equals 0, then we will only get FE equals 0. So we can say that FE doesn't contain any forces, be it compressional or be it tensional. There is no force acting on FE member. Now let's focus on the vertical axis. Here summation of f of y, which is positive upward, equals 0. Then we will get a FB, or we can say BF, whichever you like. BF, which is acting upward, so we will take it as positive, and then 200 tons, which is acting against it in the downward way, so it would be negative 200 equals 0, equals to BF equals 200 pounds, so 200 tons. And since this is in positive, so we can say that the BF member is in tension. So there we have it, the member BF containing 200 tons of tension force, and the AB, which contains minus 282.84 tons of compressional force. And then we can say that AF, which is carrying 0 load, and FE also carrying 0 load. And that's it for this math. Hope this is useful to you. Thanks for watching.